this example is like in number 45, and we have something like this. It's not too bad. We have a fraction. We add this fraction. We can get a positive. We can get a common denominator. So that's what I'm gonna do. That's what I'm gonna do here. So I'll times it by 3. Hey kid, what you doing, huh? Times it by 3. And times it by 3. That really doesn't do anything on the right side, but because I have 0 there, it doesn't matter. Then I would get, so I have a fraction, so I'll get a common denominator. That's actually one of the reasonings that we could say. And then 3 times 3x squared is 9x squared, plus 3x minus 2 equals 0 still. And remember, anytime we have an equal sign and we get a common denominator, we can get rid of the denominators. So there we go. Then, looks like I can do big X. So what was in top? 9 times negative 2 is negative 18. And 3 in the bottom. Ooh, 6 times 3. 6 times 3 is 18. Is that true? Is it true? Is it true? I think so. And then a negative, it would be a negative 3. But I cannot use the shortcut because I have the 9 there. So I have to have 9x squared plus 6x minus 3x minus 2 equals 0. And I can do that step. I can put that step right there. I can divide that by 3x. So I get that 3x on the outside. And I get 3x on the inside, right? That's what I get there. And here I get a plus 2. And I can divide by negative 1. And that gives me 3x plus 2 as well. And so I know I'm doing it right. And remember, well, these are the same, so I can factor that out. 3x plus 2 on the outside, and then the leftovers on the inside. I have 3x minus 1 equals 0. But remember, it says to solve, so I have to get one more step. And that's just setting each piece equal to 0 and solving. So I could subtract 2, 3x equals negative 2, and divide by 3. So I get x equals negative 2 over 3. There we go. That's one answer, but I get two answers. 3x minus 1 equals 0. I could even do this in my head. 3x equals 1, divide by 3, divide by 3. I get x equals 1/3. Yeah, there you have it. That's how you do that problem. What is the reasonings? Okay, so we got a common denominator because we were adding or subtracting fractions. Then we had a trinomial, so we could do big X. So that's one of my reasonings. Got a common denominator because we were subtracting a fraction. That was that minus 2/3 there. And then we did big X. Big X because we had a trinomial. A trinomial. And I couldn't divide anything out of it. I couldn't divide by 3 or something because of that minus 2 there. So that's what we have that for that problem. That was what we have. For this example, it says to find the zeros, and we know how to do that. Find the zeros of the function. We just take that and we set it equal to 0, right? And we do that, and then oh, this is something that we've done already. We know how to do this. What do we do? Well, looks like we can do big X. Let's try that. 121 in the top, right? Because it's 1 times 121, and 22 in the bottom. Well, I already know. 11 times 11 is 121. I add them together. That's 22 also. So I get, oh, and I can use the shortcut. X plus 11 times x plus 11. So I'm solving for the zeros. So the zeros are x equals negative 11, and x equals negative 11, right? It happens twice, so it bounces there, but that's it. That's all. We're done. The zeros are, so those are also the x-intercepts. X int and 0. Right? Because it's a 0, because we made it equal to 0. But a 0 is the same thing as an x-intercept. So there you go. That's what you have. Those ones, you can all factor them. 47 through 54. You can factor all of them like that. So yeah, the only one is 51. You have to use the long way. But we just saw how to do the long way. So I think you should be good on that assignment, and I'm going to let you do it. Have at it now. Don't get lost.